Okay. Hello, everyone. First of all, welcome to our webinar today, and thank you very much for your time. So today we will be talking about new technology, which we call Advanced Design Connections. So it's a software that you can use in design of your steel connections, and it is based on technology called component-based finite element analysis. So according and using this software, you will be able to have much more easier modeling, and you will have more detailed and accurate results. So I will continue with our slideshow right now. So first of all, the agenda of webinar today, we will talk about Greater Group presentation briefly. After that, it will be introduction to ADC. I will talk about the geometry of connection, how to apply load effects, design and manufacturing operations, results and code checking feature, types of analysis and local buckling modes, templates in ADC. We will see how you can export a model from advanced steel to ADC. We will see the report generator feature of ADC. We will see a success story of static company that they have used ADC in one of their projects. And after that, we can have questions. So who is Greatech? Greatech is a company with 30 years of experience in CAD and BIM and design solutions. We are developing our software, so for structural engineers and technicians all over the world. We have 36 offices in most of the countries in the world, USA, Canada, UK, France, and all of the other countries. We have 450 plus employees and still growing. We have a global reach using our network of authorized resellers in all of those countries. And we are the third biggest worldwide Platinum Autodesk partner. And the revenue of the company currently is over 100 million US dollars. And I just want to add that we have a local North American team here based in Montreal, that we have our developers and technical support to localize our software according to North American codes. Okay, let's talk about ADC. So as I told you, it's a software based on component-based finite element modeling. So what does it mean is that in your connection, normally you have different components. You can have your sections, you can have special plates like end plates, you will have bolts, welds, and other components. So to analyze all of these components all together, what ADC does is transferring all of these entities to components, as you see here in this model. For example, here I have shown you the bolts. And after that, theoretically, we are transforming these components to finite element plates or finite element members. As you see here, for example, here are bolts. They have been modeled as spring elements. And after that, we will have an analytical model to use it and define our geometry, and then the analysis will be done using finite element method. So component-based method is briefly just transforming your geometry to simpler elements and then do the analysis and design based on the forces coming from your elements. So briefly talking, there are two very important aspects of software. First of all, the plates that they can be webs or flanges or other end plates. They are meshed using shell elements in ADC that can be easily modeled, and you can have access to results of finite element plates, like you can have your stresses, strains, and internal forces. And for the bolts and welds, we have developed special finite element geometry. So you will have special behavior modeled correctly and most and close to the reality using these special bolt and weld elements. So these are two very important subjects that I wanted to talk to you. So now I'm going to show you an overview of the GUI, and I will continue the rest of the webinar directly on the software itself. So let's go directly in Advanced Design Connection. Okay. So first of all, I'm going to talk about the GUI first. So when you open Advanced Design Connection, you will see this window here, which is starting of a new project. So as you see here in the left column, we have standard Windows options. So you can start a new project. You can open your project using the file. You can save it. You can save it as any name you want. If you have some information on the model, you can access them from here or modify them. You can see the about software like version and other related properties. You can change the units of the model or project using this option here. So if I click here you have all of the units as default. So as you see, the length default is meters, but you can change all of these units in order to define your projects. We have preferences that you define in your model. So these are almost standard preferences that you can have. For example, the color of displayed entities in your model. You can have logos, and you can change the language from here. In this option here, you can access your license of ADC to see, for example, is it expiring, license information, and other kind of information. You can close your project here, and finally you can exit from the software. So I'm going to start from the new option here. So as you see here, we have plenty of predefined geometries of connections in ADC. So for example, here it's just simple beam to column connections. Here you can have beam to beam connections. Here you have some bracing connections. We have also encouraged design and analysis in ADC, and here you can have a three-dimensional, completely three-dimensional geometry to start your model. And as you see, each of these categories, they have several subcategories. For example, if you go with this kind of connection, you can change it. For example, you can have this kind of weld and stiffener. You have this configuration also to start with. So you can start without any kind of connection, and after that you can add it. So these are the default geometries that you can start with those. So let's say if you have an HSS, you can start from this kind of connections. So all of these categories, you have subcategories that they are related to each of them. So for example, we can have this kind of base plate in your model. And after that, that you have selected your starting geometry, you can start and modify your default steel grade. You can change your bolt assembly. You can define the weld grade, and you can change the concrete grade for the foundation. Finally, here you can check the design code. We have Euro code, we have US codes, and we have Canadian codes available in ADC. In case that you cannot find your type of connection or the type of connection that you want to model, you can just use the empty project like this. So ADC will not provide you any kind of geometry or sections. And now here you can start from ground zero. You need to put your define your sections, define your connection and components manually in case that you cannot find them from the library. Okay, let's continue with our GUI. So here I'm going to just select a simple model like this, and I will use Canadian codes. Then you can click Create Project. So here is the main window of ADC that we will do the design and analysis and modeling. So as you see, ADC has built the model for me here, the connection, and it looks like exactly my default selection. So we have 5 tabs here, first of all. So the first one is about your project. So as you saw, it can you can have some description of project here, your information here, you can add them. The second tab here is design, that here you will start to design and modify the connection itself. So here you will be able to modify the sections, the material, the components. You can add your end plates, stiffening plates. So all of these modeling activities can be done here in design tab. Then we have the check tab that the analysis and the results will be provided in this tab here. We have the report tab that we will use after the analysis are done to generate our report for analysis and design. And here we have a tab also in order to define new kind of materials or customize materials and sections. So here in design tab, starting from here, first of all, in each file in ADC, you can work with several projects. So for example, here in this file, I have just one project which is named as Con1. But if I click new here, I can add another connection here in this, or another project in this file, and I can work on that connection separately. And you can use this option, this arrow, to select and switch between your connections or projects in this file. Also, you can copy the connections inside this file. So for example, you have worked on a connection like this, such as this, and you want to generate another connection similar to this, but let's say with other type of sections. So you don't need to start from the beginning. You just click copy here, and software will generate another connection here and name it as, let's say, Con2, and you will have the exactly same configuration for Con2, and then you can start to modify Con2 to follow your own design. So this is very helpful. Here we have separate or different types of analysis in ADC that I will cover it later on. Here we have our undo, redo, and save standard stuff that you have in other programs. Here we have the labels. So this is also important. So as you see here, I have some labels on my window here. So for example, this is labeled, this beam labeled as label B or beam B. This one here I have column C. So you can activate and deactivate these labels on the display using this icon. Also, we have the plates labeled. So here, as you see, for example, I have my top flange one, web, bottom flange. So all of the plates in ADC, they have been labeled. And the reason is later on you will see, for example, if you want to define a manual weld or bolt to connect your plates, this option will be very helpful for you to identify the plates. So then you will just define a weld between this plate and let's say display easily. So these are very helpful when you want to define your geometry later on. And also here we have our local coordinate system. So as you see, we have a global coordinate system, but each section in ADC they have it has its own local axis. So and normally both of all of the operations like transformations or rotations they will be done using local coordinates. So when you want to display or inspect these coordinates, you can use this option to display them or hide them. Here we have the pictures icons here. Most of the time, let's say you want to add some screenshots from your model or results, and you want to add them into your report later on. So here we use this option, and if I click new here, a screenshot of my model exactly as it looks like right now will be generated, and it will be saved in order to be used later on in your report. We have templates also in ADC that I will cover it later on this webinar. Here is the component base and the calculation and check part for our model. Here we will talk about, or it's the equilibrium of forces in the connection. So we have two modes in ADC. Either you can make software to put special supports on your supporting member, and you just apply the forces on the incoming member like beam, or you can also take care of the equilibrium of the model yourself, which in that case software will allow you to apply your forces in each location or what location that you want. Here you can export or import your loads, such as this that you see here in this table, into ADC. And here I will show you that you can add members, you can add loads and manufacturing operations using these icons here. So this is briefly the overall GUI of ADC. Of course, like other software, you have some tools here, for example, to rotate, to pan, zoom, perspective view of the connection. And here we have three kinds of display for the connection. So right now I am in solid display mode, but you can have a transparent one that you can see the plates and hidden plates, and it will facilitate also to see the welds between the plates, the transparent view. And we have wireframe view that it will just show you all of the sections as lines, and it's much more simpler kind of view. And here at the bottom you have some information regarding the code, the analysis type, and the units that you have been selected. So let's talk about a bit the geometry and how it works, and define. You can define the geometry manually in ADC. So as you see here, we have this column here, which is very important, and it's about our modeling. So if I go to the members, I can start to work and modify the members in my model. So right now I have just two members, B and C, so you see them here. So if I click on member C, all of the properties regarding to member C will be shown here, and you can start to modify them. So it starts from the section itself. So let's say if you want to change this section of member C, it's easy. You can just click here, edit parameters, and a dialog box will be open. Here you can see the section itself. Here you can change the name, and if I click this icon here, I can access the library of ADC, section library of ADC, that you have all of standard sections here, and you can select them from here. And also here you can assign the material to your section. Right now it's 300W, but you can always modify the type of material. You can customize the material here and define special properties for your material using this option here. Also, the other important feature that we have in ADC is, let's say you have a built-up section, a section that you cannot find it in standard library. So in that case, you can use this option here, which is adding a new section. So as you see here, we have several kinds of standard sections here, and here you can play or modify this section using these parameters. And these are all rolled sections. We can have welded composed sections, and also we have cold formed sections in the library. So here, these are the composed sections. All of these are, you can use them and modify them. But we have a tool here that we call it General Steel Cross-Section Tool. So if I click this here, a new window will be opened, and here I can define my own composed section. So let's say I want to build a section using an I section, like I'm going to go with this default. So this is the I section, and let's say I want to add a channel section on top of my I section. So this is the place that you can easily model those kind of sections. I just need to add click sign here at the bottom, and let's say we want to add a channel. You click it here. I will go with the default, and as you see here, ADC will add it here in the section, and afterwards you can modify this. So for example, you can rotate both of these sections. You can move them. So for example, let's say if I want to move this section 60 millimeters up, you can easily do that, and you will have your new customized section. You can add whatever or how many members that you want. It's no problem. You can just add it here using the click plus sign. And the other tool that we have here is the results. So you can access the results of the section itself here. So ADC will mesh the section for you, and it will calculate the stress points on the section based on a unitary, let's say, moment or unitary shear. So let's say here I can access my unitary MU moment around U, and these are the stresses, megapascal under 1 kilonewton meters of moment. So this is also a very helpful tool to design your connection and see the stress concentration points. Also, ADC will automatically calculate all of the sectional properties for you. So as you see here, I have all of the properties like area, moment of inertia, so section modulus, so all of the properties, they can be calculated automatically with, using ADC, pardon me. And also you can see the shear center for the section, so it will calculate your shear center. So it's a very, very useful tool that you can use to define your customized sections. If you click OK, the section will be created for you, and after that you can apply or assign this section to your model. Okay, so I'm going to close this window. So you can add or delete members using here. So if I right click here, you can add a new member. Let's say if you want to add another member at the left hand of your connection here, you can just add a new member and define all of the parameters here. You can modify, for example, rotate the member here using beta, gamma, and alpha in 3D dimensional space. And also you can move your beam or section using these options here. So for example, if I look at my coordinate system Z, and if I modify this C, for example, minus 50, of course, I'm talking about the, section B, so we should be on B, and EZ, so let's say minus 50. So as you see here, it will move your connection up and down our member. So this is how you work with the geometry itself. Also, here we have the different kind of constraints that you can apply on each model. So when you have this kind of constraints, you can apply the forces in all of directions for this B member, but you can apply constraints in the end of this member, so you can, for example, close this direction so you will not have out of plane bending in this member. So all of these limitations on members can be applied using these options here. So the default is free, so you will apply forces. You can apply forces in all of the directions. So this is how we work with sections in our geometry. Then we have our load effects, that which is simple. So you just click on LE1, which is our load case. So when you click on this load case, you will see this option here that you can apply your forces directly on the section. So as you see here, I have applied on B section these kind of forces. So I have my BZ and my MY moment applied on the section, and you can see it displayed here. You can always add other load cases. You just right click and apply new load, and you will have another load case here called LE2, which is default value are 0, but you can apply forces here. So for example, I can add an axial force of 20 kilonewton, and it will be displayed here. And afterwards, after analysis are done, you can access these load case results separately, or you can have access to the extreme or controlling case. So the next subject is about the operations, which is very important. So let's say you have defined your sections in the connection, you have defined your loads. Now you want to add your manufacturing operations. So as you see here in this model, I have two manufacturing operations, which is to cut my beams and columns. It's a kind of cut operation. And after that, I have the, if I select it here, I have the stiffeners, which are here, that already applied to this model. So all of the operations can be accessible here. From here, you can add new kind of operations. So let's say if I right click here, click new operations, we have several types of operations here. So you can have a cut, you can add stiffeners, wideners, ribs, you can add openings or notches in the section itself, you can add end plates. So all of these standard manufacturing operations, they are defined here that you can use in modeling of your connection. You can add base plate and anchorages, and also you can add stiffening members, stiffening plates. So all of these options are very helpful to help you model the connection. And here, these two options we have to just, let's say, add a bolt to your connection. So you can add a bolt in each location that you want in the connection, or here you can add a customized weld. So for example, let's say you just want to attach two plates using welds, you can use this option here. So I will show you, for example, how this works briefly. So let's start with a new project. No. So let's say I have a beam column connection like this. So I will start with just the section, so there are no manufacturing operations defined. I'm going to click OK. So I have my sections here. There are no operations. So let's add an end plate here to our connection. So which is very easy. You just go to operations, right click, click new operation, and the end plate beam connection operation is here. You just click this. So you select the default bolt assembly, but afterwards you can change this. I'm going to stay with default. Click OK. So now I just need to assign my end plate to my members. So end plate will be located on member B. So I just select member B. And as you see here, my end plate has been added to the model. Very easy. And after that, you can modify all of the properties related to this end plate. So for example, you can change the thickness of end plate. You can change it. It can be bolted or welded. You can play with the dimensions. For example, if you want to have a bigger one, you can just apply it here. And as you see, you will have a higher height of the end plate. You can also play with all of the width about this plate. You can, for example, easily create a backplate. So if I click this check mark here, a backplate will be generated for this connection here. So of course we need to modify our column, but it's just to demonstrate you how it's easy to work with these manufacturing operations. After that, you have your bolts here. You can also define more bolts. You can play with the properties of your bolts from here. You can define the coordinates or location of bolts. For example, here I have -30 regarding the ends of my plates, but you can add more bolts and change the location of the bolts. You have the option to define your bolt as if the thread is in plane of shear or it's out of plane. Also, we have the behavior of the bolt under shear force, that you can have just bearing, you can have tension shear interaction, and you can have friction to transfer the shear. And here finally you have the weld properties, that you can play with the leg size of your weld. Right now it's just the default value chosen by ADC, but you can modify the leg size. You can modify the electrode and the weld properties here, and you can decide that your weld is going to be two-sided, one-sided the side of the weld. You can also have a butt weld, and you can have just no weld and simple connecting of the plate. So all of these properties, they can be edited easily, and it will help you to model your connection. Also, we have another useful tool in ADC. So let's say you have a plate that it is not rectangular, or it has some special openings on it. So to define those kind of plates, we have a very useful tool. So for example, let's say I want to add a hole or notch into this base end plate. We have the editor feature here. So let's say you are in end plate, which is this one. If you go to editor option, so it will show you the plate itself, but here you have the operations on plate tool. So you can do all of these operations about this plate. So for example, let's say I want to add a hole. You just click it here, and here you just need to, for example, define the radius, let's say 50, and it's plated at 0, 0 coordinates of the plate. So I will have a hole here in my plate, and if I click OK, as you see, my plate as a hole. So you can easily modify the plate shapes, and you can add special geometry or configuration for plates, and this is correct for end plates, for gusset plates, for all of the plates that you have in ADC. you can modify them. Also, another very useful tool is, let's start another new model. So I'm gonna, let's say, change this. I will select this kind of connection, which is a brace cassette plate connection. So let's say you have this plate that is here, and it's a stiffening plate, SP1. You want to define a very special kind of geometry for this plate and maybe a special opening. So we have the option to import your plate from AutoCAD or as a DXF. So let's say I want to import my plate from AutoCAD. So you just need to go to Polygon here, and here you will have an option of DXF importing. If I click DXF, so I already have defined the DXF plate shape in AutoCAD. So I just open it and import it here. So you will have a new window, and here you can assign these drawings to your plate. So for example, I'm gonna tell software that use this polyline as my outline, and let's say I want to use this as my opening in this plate. So I will click opening. So this is gonna be my plate, and if I click OK, as you see here, the geometry it's applied to my plate here, and of course later on you can play with it. You can for example change its coordinates using these options. So for example, I can shift it up or down, as you see here. So all of these you can play with the plate and put it in the direction that you want. You can rotate it like using these options. So as you see, all of these properties can be applied and modified using ADC, and this is very helpful. So now that we have covered almost most of the modeling part, I will talk a bit about our results. So I will open one of my projects here, which is done recently. Okay, so let's say this is a project which is a bit complicated. So I have my several braces, I have belts, I have stiffening plates, I have my gusset, I have HSS section. So and you see all of the operations are done here. I have my members here, and I have my loads here applied on the connection. So to check the results in ADC, it's easy. You just go to this tab here, check, and you click calculate button, and ADC will start to mesh the structure, apply the special properties, and it will do some iterations because ADC is also able to do nonlinear analysis. So we just wait for the analysis to be done. Okay, we have the analysis, it's done. And the default view of analysis results is overall check. And as you see here, everything is green. So software is telling me that my connection, the bolts and everything is passing according to code. So, but you have other kind of results also here. So for example, you have a strain check result that you can check the strain in your plates here. So as you see in these green portions here, I had some high strain values, and also I can access my stress values or equivalent stress or one misses, that is for yielding of your plates or material. So here is the equivalent stress results. So as you see here in my HSS in top parts, I have very, very high stresses. So you can access the results as color codes from here, which is maximum is 235 megapascals. You can have the plastic strain results, clicking this option. which is here. So you see the concentration of stresses here in these portions because of welds and ends of members. You can access the bolt forces using these options. So software will show you the forces applied to the bolts as these arrows here. So you have your bolt names here, and you have the forces in kilonewton or defined force unit. You can check the mesh here. And you see the mesh of finite element, and you can have also the deformed shape of the structure or connection under these forces. And of course it is scalable, so you can use higher scales to see the deformation. So as you see here, this is the deformation of my connection here due to the applied loads. So the other feature that is very useful in ADC is our code check. So if you go here, software is telling us that all 100% of loads, they have been applied to the connection, and its status is okay. So if you click plates here, you will have access to design results of plates. So in ADC, what we are using is the strain limit on plates. So when the limit of a strain is less than 5%, ADC assumes that the plate is passing. So you can access all of those results one by one, and you will see the plates down here and the places of the plastic strain that happened here. But obviously it was less than 5%, so this plate, all of them are passing the design. You have the properties of material here. Also we have the results for bolts. So if I go to this option here, all of my bolts, they have been displayed here. So you have all of the values for bolt design here. You have the bolt resistance calculated based on the selected code, and you have the percentage. And also if I click plus sign here for each bolt, I have the separate design report, which is based on the defined code, which it can be US or Canadian codes, and all of the interaction equations, all of the calculation of strengths, you can access them from here one by one for each bolt separately. Also, same thing is correct for welds. So if I go to the welds, all of the welds in this connection, they have been designed. You have all of the stresses in the build, you have the percentage of the force to resistance, and you can access the weld design report one by one here using this option. So you have your design results and you have your analysis results for the connection. So this was just a steel connection, but we can also open another model, which is a base plate model that I'm going to just show you briefly. So you can also access the concrete results based on your base plate and anchorages. So you can have stresses in concrete, you can have the strengths automatically calculated for anchorages. So all of those results you can access using ADC. So we have other very useful tool in ADC that I want to mention, which is templates. So if I'm in design tab here, the templates, so let's say you have this model and you want to save it as a template, and let's say send it to a colleague that maybe they don't want to start from beginning and they want to use your template and just change the sections in order to facilitate and accelerate the modeling effort. So you can just create your template here, click create, and ADC will create a template for you. I'm going to just click it here. So this is the template. You can name the template here, and afterwards you can use this template in your other models starting from the beginning. The other very useful feature is advanced steel link to ADC. So I'm going to show it to you right now. I'm going to close ADC first. I'm going to open my advanced steel, which is here. So I will open an advanced steel model that I have defined before. This is a model. Click open. So this is a model in advanced steel. So let's say I want to export this connection from advanced steel into the ADC. So we have a special command for that, which we call concheck. So if I click enter, it will ask me to pick a point for my connection, which is going to be this. After that, I need to select my members to this connection, click enter, and then I just need to select the components of the connection, and I'm gonna just click enter, and now all of this connection will be exported into ADC. So as you see, ADC is automatically opened. And as you see here, I have my connection already imported from advanced steel to ADC. So all of those manufacturing operations are here, as you see here, and afterwards you can just start to apply your forces or modify your model. After that, I just want to show you the report generator of ADC. So when you have done your analysis, you can just go to this tab here, and ADC will generate a standard report for you, and all of your results, properties will be included in this report. And here at the bottom right, you can modify the report, you can modify the screenshots that you want to add from your gallery that you have, I've already spoke about it. So all of this report is modifiable, and you can modify it, regenerate it, and afterwards you can export it as a document format or PDF format. So this is also very useful. So so far I have covered almost most of the features in ADC. I'm just going to show you a success story of one of our clients, which is Stantec. So here it's a temporary support structure for a long span bridge construction, as you see here, and we had two connections to design. So these are the elevation or detail view of the connection. So here we have a vertical to horizontal member connection, a bolted connection like this. And here we have a much more complicated connection. So all of the analysis and design procedure of the connection, it has been done using ADC. And in my next slide, I will show you those results. So as you see, this is the first connection and this is the second connection. And as you see, everything is passing. Here I have just two bolts which are very close and negligible, so 100.1, it's the design load ratio. So this structure and the connections, they have been analyzed and designed using ADC, and the structure is constructed right now. So this was also a kind of success story that I wanted to share with you. So I guess this, yes, concludes our webinar today. So first of all, I just want to remind you we have a 20% of rebate on the software until April 30th. So you still have time to request a free trial and try the software, and if you want to purchase it, you will have this 20% rebate until 30th April. So because we are almost our time is very finished, so I will ask you to any kind of if you have any kind of questions, just send those questions to our support here, which is support.americas@greattech.com. And also, if you have any kind of free trial requests, I can just send the request to this email, and we will be very happy to provide you a free trial or any kind of support you want. Also, I'm checking my webinar information here. I'm not seeing any kind of questions, so I guess we are okay. Again, thank you very much for your time today, and I'm wishing you and hoping you a good time and having fun software. Thank you very much, and goodbye.